The most reliable way to fly is to let the imagination soar. In the beginning, flying was something for adventurers to do on a dare. Dreamers, pioneers, aviators, and ingenious scientists set a course for air and space flight far into the future. Passion, unique discoveries, and awe-inspiring inventions set the stage for the vision of flight. Preparing to make that first big leap required a bit of avian know-how. It all began with the bold quest of an engineer from Berlin, Otto Lilienthal. Lilienthal took to the air with hang gliders he made himself. The flights were short.
Lilienthal
wanted to find out exactly how birds flew. So he watched them. Using a scientific approach, he augmented the observations with his own experiments. That's what predestined him to become the first researcher to explain how propulsion worked. Until then, it was a real riddle.
Lilienthal studied the characteristics of birds' wings, such as storks, for example. Observation led him to make a key discovery. Storks' gently arched wings produce the lowest resistance and the greatest lift. Lilienthal was laying the groundwork for new inventions. Flight was merely a step away. Taking off into the wind worked, just as it did for birds. In 1891, Lilienthal flew 15 meters. Soon he was making flights of up to 300 meters, until August 9, 1896, when he fell to his death. In 1900, Imperial Germany is flying high, a technologically advanced great power. The tap of the telegraph revolutionizes communication and sets the beat for Germany's spin through the exciting days of the avant-garde. Rail lines link one corner of the country to another, and the gramophone is popular. In the coming years, 23 Nobel Prizes are awarded to German scientists, and Count Ferdinand von Zeppelin is soaring high above Lake Constance. The conquest of the skies is starting. In 1907, the Motorized Airship Research Company is set up in Göttingen. The first institution devoted to aviation research is equipped with a wind tunnel designed to investigate the problems of flight. An electrically powered fan is used to generate a current of air inside a large tube. Motors and propellers are designed and specially made for the unique piece of testing equipment. The closed wind tunnel is the first of its kind and marks a milestone in the history of this type of testing technology. The first experiments are carried out under conditions of controlled airflow.
At
the time, airships, rather than planes, were really the passion of flight enthusiasts. At the turn of the century, Zeppelins were already a recognized means of air transport. But there was little knowledge of aerodynamic laws. What was the shape that would optimize the movement of an airship through the air?
The real work begins. The first measurements are taken after a turbulence-free airflow suitable for experimental purposes is generated in the tunnel. Among the data recorded are drag, airflows, and pressure distribution. The optimal shape for an airship is still a mystery. Airship designer August von Parseval is the first to commission the Institute to investigate and develop his designs. Parzival draws attention by making experimental flights that are longer than 1 hour. On the eve of World War I, Germany leads the world in the development of dirigibles.
Before 1910, airships were built every which way. Some were pointed at the prow, others at the stern. Some looked like cigars. There were long ones, short ones. Every possible shape and size was represented. After the data were gathered and assessed at Göttingen, all the world's airships looked the same. They were slightly rounded at the front and gently pointed at the rear.
Balloon races become fashionable. The controversy begins in earnest about whether something heavier than air will ever fly. The dispute does nothing to dampen spirits. Aims remain high.
France had a head start when it came to aviation research. Germany had to catch up and managed it with the help of people like Count Zeppelin. So heady was his reputation that it was lighter than air. Based on this and a wealth of experience, he became the person who set the tone for the future and can be credited with putting the study of flight on an institutionalized scientific footing.
Powered flight is not far off. After thoroughly studying Lilienthal's work, 2 American designers, the Wright brothers, become the first to make a motorized flight in 1903 in a craft that's heavier than air. Many are willing to risk life, limb, and becoming a laughingstock in experiment after experiment. Oftentimes, their contraptions do everything but produce the desired result. The idea of flight sends the fancies of dreamers, inventors, and serious aficionados soaring, leading many of them to be scorned by others as visionary lunatics. In 1904, the hydrodynamic engineer Ludwig Prandtl makes a startling discovery that revolutionizes the up-and-coming new science of aerodynamics. He describes the boundary layer, where all airflow changes occur. The discovery brings Prandtl recognition from all over the world, including Russia and later the United States. Then in 1909, Prandtl is made the world's first professor of airship flight and aeronautics. And his scientific writings, such as the wing or lifting line theory, create a huge stir and become one of the key cornerstones of aerodynamics.
The boundary layer is in immediate contact with an object's surface. The greater the distance from the surface, the more the layer conforms to its surroundings. Considered mathematically, the boundary layer is a bit of a simplification. Ludwig Prandtl applied this trick in 1904 to calculate and describe numerically currents along the surfaces of different objects.
Scientists of aerodynamics meet at the world's first aeronautics congress in Göttingen in 1911. It's one of the first times that the benefits science could have for aviation are discussed in an open scientific forum. Aerodynamics and the mechanics of flight are addressed. In the same year, a student of Prandtl's, Theodor von Karman, publishes his theory of vortices, the swirling motion of gases behind an object after they've moved over it. Air shows are the latest diversion. To get their thrills, Berlin residents flock to the quiet suburb of Johannisthal on Sundays. In 1909, flyers, daredevils, give excited spectators the show they want to see in the skies above one of the first German airfields to feature motorized planes. Even the Wright brothers are buzzing Europe. Crown Prince Wilhelm, here speaking to Orville Wright, is impressed. German pilots should sit at the round table among the new knights of the skies. Aviation pioneers begin to pit their homemade machines against each other. Fortunes in prizes go to the fastest flyers. The imperial court and industry offer stakes as high as 20, 30 or even 40,000 marks in gold.
During the early years of flight, progress came as a result of trial and error. You built a plane knowing it needed an undercarriage and 2 wings. But beyond that, everything, considerations like how fixed the wings should be or what would create the least drag, was a big grey area, nebulous and unknown. Everyone was tinkering in their workshops and sheds. Mechanical skill became the means to pursue the dream of building a flying machine, but without any scientific qualifications. They simply made contraptions and then tried to see if they would fly.
Clattering flying machines have their charms. To begin with, French, British and American inventors steal the show from the German aviators.
Early on, there were n numbers of experiments, meaning they were countless. There were planes with the engine in back. Some had 5 or 6, even 7 wings. They tried everything. The times were creative and nobody knew exactly where it was all headed. Anyone was free to experiment. But the risks were high. Attempts to discover if their ideas really worked cost many early plane builders their lives.
Aviation pioneer Hans Grade moves Germany back into the spotlight by winning the Lanz Aviation Prize in 1909. The triumph helps the country regain ground. To win, Grade had to fly a horizontal figure of 8, some 2.5 kilometers in length. All parts of the aircraft had to be from Germany. The plane's builder and pilot had to be German as well.
The technological leaps were spurred by ready cash. Germany had registered that aircraft were being built in all the neighboring countries. Even France, known to some as the hereditary enemy, had already built many planes. But us? We didn't have a thing. It's a simple technical fact, understood by every engineer and scientist. If the money's there, then research will progress. Soon there was discussion about whether the entire development shouldn't take place under the auspices of a larger scientific organization. A scientific institution had to be set up to address these questions, which had previously been tackled by in-flight experiments.
The German Aviation Testing Establishment, or DVL, is set up with the signing of a charter in 1912. The compound at Adlershof becomes the aviation research center of the nearby German imperial capital Berlin.
In 1912, they began to build research institutes at breakneck speed, and not just hangars and airfields, but wind tunnels and testing rigs for engines with all levels of horsepower. A large concentration of research hardware and personnel were located here. That did nothing to impede synergies with other research establishments, while it remained a place where one could work relatively independently.
A veteran aviator and airship pilot, Major Georg von Tschudi, becomes the director of the nearby airfield at Johannisthal. The area is ideal for test flights. The landscape of the marches becomes a home for departments engaged in researching the physics and technology of flight, in addition to the site for a number of test rigs. Engine overheating plagued the early years of flight. Some of the best-known aircraft makers of the time settle near the gates of the DVL compound to improve their craft through systematic application of scientific research and to establish a link between industry and research. The military expresses its interest as well. War breaks out in August 1914. Planes become weapons for generals to deploy. More maneuverable, faster, and with a far better vantage point, the aircraft replaces the cavalry as a reconnaissance tool. Contemporary heroes are Immelmann, Bölke, and Udet. The day of the elite fighter pilot dawns. Conquering the skies is taken literally. Research is now done in the name of war. Fighter production begins, and the first one-seater planes are delivered to the front. Men like Manfred von Richthofen, the Red Baron, fight their way to fame and fortune. The age of the flying ace has arrived. Bombers and gunships are built and increasingly deployed against strategic targets. Plans are made to build a larger research facility equipped with bigger wind tunnels. In 1916, an aerodynamics testing center, the MVA, is built in Göttingen.
During World War I, military resources were used to drastically enlarge the research establishment at Göttingen. A much larger wind tunnel was built there, and in both the small and the new larger tunnel, a series of experiments were carried out on wing cross-sections. Seen from an empirical standpoint, this was the start of the scientific study of aerodynamics.
The new tunnel sets the standard for similar testing facilities the world over. It generates wind speeds of up to 180 kilometers an hour and lends its name to the wind tunnels that follow it, the Göttingen type.
A number of airfoils designed and developed by different aircraft makers were tested in the Göttingen wind tunnel. Results for the different airfoils were published in anonymous technical reports, so that one manufacturer would not know what another competitor had developed. In Göttingen, they simply numbered the airfoils and tested them and some of their own different designs, sometimes varying them slightly. They then recorded the aerodynamic data. During the First World War, the data was stored in files that were either secret or accessible solely to the manufacturer that had created the design.
Wing prototypes designed at Göttingen become the industry standard for decades to come. Anyone, anywhere in the world who wants to build an aircraft uses them as a guide. The name Göttingen goes down in aviation research history. Testing wings by loading them with sand sacks and 42 troops leads to the development of a new branch of research, aeroelasticity. A model train pulls a test rig in the Göttingen wind tunnel. A life-size version of the experiment is conducted later, south of Berlin, on the military railway near Jüterbog. Propeller test rigs run on rails. The aerodynamic shaping of wings, fuselage, propeller and other components, and certain types of engine are the scientific fruits of World War I.
If you consider the changes in the look of planes between 1914 and 1918, it really becomes clear that a major leap had taken place. 1918 vintage planes flew considerably higher, were faster, and could carry greater loads, bombs in this case. By the end of the war, plane designs and technologies had greatly improved.
Anthony Fokker builds the first one-seater monoplane fighter. Hugo Junkers makes using wood for aircraft a thing of the past when he builds the J-1, the world's first metal plane. But aviation progress did nothing to avert Germany's defeat in the war. The armistice is signed on November the 11th, 1918. The 1920s roar into life as Europe recovers from the war. Everything is new, exciting, and ever so modern. It seems the whole world is a big dance hall. But in the Treaty of Versailles, the winners of the war hand Germany the bill for its earlier aggression. The country's aircraft are scrapped. What Allied forces, Britain, France, and the United States, can't use is decommissioned, dismantled, and destroyed. Even aircraft engines end on the scrap heap. Soon the hangars are empty. German aircraft are never again to be used to wage war. Competitive German plane makers are closed down. But the setback becomes a turning point. Now experiments in Göttingen are focused on completely different models. The streamlined Rumpler-Tropfenauto is tested in 1921. Though it's more than 6 decades ahead of its time, the low wind resistance multi-passenger car is never mass-produced. By 1923, the Research Institute staff has dwindled to 15. A model of an express train is also subjected to the artificial airstream. And drag measurements are taken for Daimler racing cars clad in streamlined hulls. The cars eventually reach speeds of 190 kilometers per hour. The wind tunnel is also used to prepare prototypes for gliders. The aviators have found a loophole in the restrictions placed on them by the Allies. The Treaty of Versailles mentions powered flight only.
What do you mean we're grounded? Impossible. The ban on motorized flight in the Versailles Treaty led to the start of a great new development in aviation, the glider. Aficionados and experts met on the Wasserkuppe. Looking at these contraptions made of nothing more than wooden spars and stretched cloth, it's really amazing that they actually flew some 200 to 300 meters and stayed up in the air for a minute or two. Sometimes banning an activity can have unforeseen effects that have little to do with the ban's original purpose. While one activity is stamped out, something else springs up in its place.
Gliding is the only way for Germany's aviators to fly. By 1920, they're already holding the first gliding competitions in the skies above the highest peak in the Rhone Mountains, the Wasserkuppe.
The project in this case was to develop aerodynamic specifications for gliders. A scientific foundation for soaring was to be laid that would address meteorology in particular, and the knowledge of air currents, which are both key to gliding for long distances. This clearly demonstrates how gliding became a vital component of aviation research.
A short time later, German pilots are able to resume powered flight. Mail and passenger services are among the first to take off. The first airlines are opened. Dornier builds its famous flying boat, the Whale. The plane makes history when in 1926 it becomes the first aircraft to cross the South Atlantic. The Junkers F-13 becomes the first passenger aircraft in the world to be built of metal. The newly established German airline Lufthansa uses the F-13 as a workhorse to gain preeminence in the skies. An unintended consequence of the Versailles Treaty is that Germany is able to build planes that are aerodynamically superior because they may only be powered by relatively weak motors. Construction begins in 1924 on the new institute building at the Kaiser Wilhelm Institute in Göttingen. The MVA has been known as the Aerodynamic Testing Establishment, or AVA, since 1920. Plans are unveiled in 1928 for another wind tunnel. The measurement area is to be 4.5 by 7 meters, one of the biggest of its kind at the time. A few years later, the first specialized wind tunnels able to generate wind speeds in excess of 900 kilometers an hour are built. Adlershof has been equipped with additional motor and propeller test rigs by the end of the 1920s. They're also used to evaluate the airworthiness of aircraft in a sort of standardized series of tests for planes. Dressed in an elegant suit, Leslie Irvin came all the way from Buffalo, New York, to test his air chute or free-fall parachute. After tests at Johannisthal Airfield, the new invention is certified as safe in 1929. During World War I, flyers rejected parachutes as being beneath their honor. But by 1930, they're being used by more than 40 air forces. By September 1930, imaginative, innovative individuals cause a commotion by taking aim at the stars. A group of pioneering, daredevil, enthusiastic hobbyists begin carrying out dangerous combustion experiments with liquid-fueled rockets. Ranging from visionary to crackpot, they're united in the hope they will soon send rockets into space. The former parade ground in Berlin's Tegel district becomes the proving ground for these completely unpredictable flying objects.
The idea of interplanetary spaceflight wasn't just being bandied about, it was extraordinarily popular. There were big fan clubs with large memberships and comprehensive literature that, from a cosmic standpoint, was actually very far-reaching. Flights to Mars were discussed, as were types of satellites that we can't even now imagine. They were visionaries.
They fire more than 100 rockets into the skies above Berlin. Lampooned by some as the Tegel Jokers, the hobbyists are paving the way for space travel.
Rockets were intended to compensate for the loss of national and government power. Leading German scientists were thinking about spaceflight. The title of Hermann Oberth's trailblazing work showed where things were headed: the rocket into interplanetary space. There were loads of rocketry clubs, amateur rocket builders associations. Rocket mania was widespread among the general population. Fritz Lang's films were right on target. Rockets were the thing in Germany in the 1920s. Opel's rocket car was another example. This enthusiasm was something scientists could build on.
People everywhere seem crazy about rockets, not only in the skies over Brandenburg, but on the road too. Even one of Germany's greatest automobile makers of the time, Fritz von Opel, wants a piece of the action. The physicist and spaceflight pioneer Max Valier conceives of a car capable of explosive speeds, and Opel is to drive it. Forget the engine, the rack too is powered by 24 solid rockets. A crowd of 3,000 watch a test drive on the city's racetrack, the Avus. The trip takes 2 minutes, with the rack 2 reaching speeds of 200 kilometers per hour. There are demands to step it up a notch. Designers produce a rocket-powered car on rails, but they daren't ask any human, not even Fritz von Opel, to drive it. A cat is at the controls. Some 300 kilograms of dynamite go off with a big bang. For the record, a comforting note says that the cat survived with minor injuries. One young Berlin rocket man is going to make a name for himself in the future. Werner von Braun's career begins when he takes a job at an experimental site in Kummersdorf near Berlin. It's 1933, and preparations for the military use of rockets are getting underway. The task is to test rocket engines for use in missiles. Air travel gets a majestic boost when the colossal Dornier X becomes the pride of a country crazy about flight. It's the world's largest aircraft and seats 160 passengers. In an unparalleled triumph, the technical wonder arrives in New York City from Germany on August the 27th, 1931. The Junkers W-33 also rises to fame when it crosses the Atlantic. Some say it's flight's golden age, given even extra glitter by many new designs and developments, such as the Junkers G-38. Germany is again the mecca of aviation research. Experiments are promoted by the state, but science retains its independence. An enormous concrete egg is built in Adlershof. It's a vertical wind tunnel for evaluating what forces affect an aircraft in a spin. It's also to help determine what causes planes to crash for seemingly no reason.
These were tough times for aviation. The technical possibilities of flight went far beyond human capabilities to control them. So it was decided to set up scientific establishments where it would be possible to investigate scenarios under controlled laboratory conditions before disaster struck. That's why they built the vertical wind tunnel, to learn more about the dangers of the flat spin.
A model plane in free fall. DVL test pilot Richard Perlia will replicate the experiment with a flat spin in reality.
I was really fascinated by flat spins. You usually couldn't get out of them. I flew a Messerschmitt 31 with low-slung wings. It was filled with lead pellets for the test. When I reached 3,500 meters, I was to take my foot off the gas and pull the stick back as far as it could go. That really went against my instincts. Then I was supposed to hit the rudder. I always sat on the left, even in the two-seaters. The plane went into a real flat spin. 18 spins were planned, but after 11 full turns, I was getting a little dizzy. So I looked down and I picked out houses and a church tower. Then I started to count. 11, 12, 13, up to 18. That was it. I was supposed to pull out hard. If I'd moved the stick the wrong way, I wouldn't be sitting here now. The worst thing was the stick kept jumping around. It was as if the rudder was no longer there. That's a flat spin for you.
Progress is also made in the development of rotor-driven aircraft. On June the 26th, 1936, the world's first fully controllable helicopter, the Focke-Wulf FW-61, makes its maiden flight. On the fourth try, it remains airborne for 16 minutes. Buildings are going up everywhere, in Adlershof, in Göttingen, and starting in 1936 in Braunschweig, where the German aviation research establishment DFL is being set up. The wind tunnels here have awe-inspiring dimensions. Some are up to 40 meters in diameter. Wings and even entire full-scale aircraft can be tested here. In 1935, Germany unilaterally withdraws from the Treaty of Versailles. During this period, nearly 30 million Reichsmarks flow into research. The test facilities have to be adapted to the more powerful motors and larger planes. High-speed and high-altitude flights are on the cards.
The big wind tunnel was for slower planes. During the years it was being built, it was planned to generate airspeeds of up to 65 meters per second. That's a little over 200 kilometers per hour. Those were normal flying conditions for passenger and transport planes. And the tunnel's large 14.5-meter diameter made it suitable for testing life-sized models, which produced excellent results.
Research gets underway on a grand scale. By the end of the 1930s, several thousand people are employed in German aviation research. Europe is getting smaller. A flight to Rome takes just 10 hours. The Junkers 52 becomes the epitome of a mass-produced aircraft. At 5,000 in the series, it's the most frequently built plane of its time. Trademarks like metal construction and low-slung wings make it one of the most modern, robust, high-performance aircraft of its time. Scientists in Göttingen get involved in the study of a mysterious phenomenon known as flutter, which destroys wings and parts of planes' stabilizers, elevators and rudders at high speeds. A Junkers 288 is put to the test in Braunschweig and a Heinkel 219 in Göttingen. The result is the discovery of new ways to prevent flutter that are still applied in building aircraft today. Test flights for Project X get underway in 1938. The revolutionary new plane is propelled by a rocket. After a series of setbacks, the first rocket-powered Messerschmitt 163 takes off in 1941. A decade ahead of their time, the fighter's aerodynamic wings were developed on gliders being flown while Germany was still subject to the restrictions set in Versailles. The plane's speed at takeoff was unimaginable at that time. The Messerschmitt 163 is what's known as a flying wing aircraft. It's capable of flying almost as fast as the speed of sound. In Germany, designers like Lippisch and Horten favored flying wing aircraft or planes without a fuselage. Their visionary designs date back to their gliding days. The National Socialists have been in power since 1933. Military research has top priority. A model of the first German aircraft carrier, the Graf Zeppelin, is tested in one of the wind tunnels at Adlershof. Poorly designed, the vessel is never deployed in military action. More new planes take to the skies. Flight gathers new impetus. In 1938, Hans von Ohain had developed the world's first turbojet engine. The Messerschmitt 262 is the first operational turbojet fighter aircraft. A German scientist speaking at the Volta Congress in Rome in 1935 introduces a revolutionary theory concerning lift when flying at speeds greater than that of sound.
A
German professor from Göttingen, Adolf Busemann, attended the Congress. But his presentation drew little attention, even though he told his colleagues how to design a plane capable of flying at supersonic speeds. Wings attached to the fuselage at right angles had to be scrapped. Instead, the wings had to be angled back and became known as swept wings.
Aircraft wings are being redefined. Swept wings represent an aerodynamic breakthrough still being applied today. Wing prototypes for high-speed aircraft are tested in the wind tunnel, and patents are filed for ground-adjustable wing sweep, which was invented in 1939. Science is running ahead of the clock. The idea of modifying wing sweep comes too late for the first generation of turbojets and too early for the second generation, leaving the Junkers 287 at the experimental stage.
Soon it became clear that there was no way to outgun the three great economic superpowers, the Soviet Union, Britain and the US. We figured we had only one chance, and that was to use quality to make up for our quantitative deficits.
The search for a means to counter Allied air superiority begins. Engineers develop the Fieseler 103, an unmanned flying bomb steered by a guidance system. The world's first cruise missile is called the V1, with V standing for Vengeance Weapon. The missile brought destruction and suffering to many. Different generations of guided missiles are tested in the wind tunnels. Until 1945, Germany is a center for the development of air and spaceflight technologies that will continue to impact both civilian and military aviation well into the second half of the 20th century. One of the most ambitious projects at this time is the development of a ballistic missile, the A-4. The rocket is 14 meters tall, weighs 14 tons, and can generate 25 tons of thrust. To promote the project, the Third Reich's most expensive, elaborate, top-secret program is initiated at Peenemünde on the Baltic coast. A research establishment and rocket factory are set up on a scale previously unimagined. More than 6,000 scientists and engineers and 13,000 support staff begin working to achieve the dream of putting a rocket into space. But at the same time, they're building a new weapon that will fundamentally change the way wars are waged in the 20th century and beyond. In the shortest of times, breakthroughs are made in the key technologies of electronics, radio, guidance, and stabilization. The A-4's engine is 17 times more powerful than those that have been built before it.
Es sind riesige Forschungsanlagen entstanden mit Tausenden von Mitarbeitern.
They built enormous research complexes that had thousands of staff members. You could certainly say it was big science. For the sake of efficiency and to carry out all the tasks set them by the aviation industry, 3 8-hour shifts kept the place running round the clock. In Germany in the 1930s and 40s, the demand for aircraft and materials tests was huge. The day of big science had arrived.
Progress is also being made again in the wind tunnel. Airspeeds of Mach 4.4 have been generated to set a new world record. In 1941, an A-4 prototype is set up in a test rig at Peenemünde. Werner von Braun is in charge. He combines scientific excellence with opportunism. His dream is to send rockets to the planets. For him, the V-2 missile, which some describe as a wonder weapon, is the necessary means to achieve that end. Von Braun never expresses ethical reservations, even when prisoners of war are used to produce the missiles. The military testing establishment is a highly efficient research center. One key to its success is everything under one roof. The close ties between the state, research and industry set an example for major scientific projects in the future.
Das kann man also durchaus objektiv sagen, dass die deutsche
Today you can objectively say that German research and development focused not only on building rockets, but on establishing the scientific principles of spaceflight, from aerodynamics to guidance. By thinking all the data through, Germany had already developed more advanced concepts. In America and the Soviet Union, rockets were being built, but only on a selective and ad hoc basis. Until 1945, only Germany conducted a consistent aviation technology development program. You can say that at this time we were really far ahead of all the others. You can emphasize that without being presumptuous. It's a fact on which today's experts from the East and the West agree.
After 7 years of work, the first A-4 rocket is successfully launched on October 3, 1942 at Peenemünde. It's the first time engineers have been able to send a rocket some 100 kilometers into space. The space age is dawning. But Peenemünde is also a symbol for the dark side of science. Some 30,000 prisoners die building the rockets, and 5,000 people are killed when they're deployed. Germany's misuse of the fruits of its fascination with flight comes back with a vengeance, but the country lives to fly another day. A decade later, Germany returns to the upper echelons of international air and space research. A Century in Flight. Part 2 of this documentary addresses the years from 1945 until the present. Flight took daily life to new heights. It changed perceived limits of time and space. Just a few decades after ingenious and courageous pioneers of flight tried their luck with a contraption made of slats and sailcloth, engineers had mastered the art of applying complex technologies to the construction of aircraft and rockets. But that's only the beginning. The conquest of the skies continues. American, Soviet, British and French troops marched shoulder to shoulder through the Brandenburg Gate in Berlin in 1945 for the first and the last time. Historic events also take place in Potsdam. The trio of leaders known as the Big Three, Winston Churchill, Joseph Stalin and Harry S. Truman, sit down to redraw the map of post-war Europe. They put on a show of harmony for the cameras. Germany is in ruins. Air and space research is prohibited. The German laboratory for aviation at Adlershof is dismantled and carted off to the Soviet Union in pieces. The British take the wind tunnels in Göttingen home with them, and the Americans and French gain from the spoils of war as well. Allied planes have sovereignty over German airspace. Liftoff after the war. Researchers prepare to launch A-4 rockets in the deserts of Arizona and New Mexico. The race to exploit German know-how begins. The top-secret US Special Mission V-2 ships 100 German missiles and 14 tons of documents, the entire archive from Peenemünde to America.
We in the United States and of course in Britain and France and the Soviet Union all inherited this wealth of new research that had been funded in the late 1930s and in the early 1940s in Germany.
The foundation for space and rocket programs of the coming decades is being laid, but not in Germany. It's become clear that countries seeking global power must have the latest technologies at their disposal. Among the technologies transferred as spoils of war is the Flettner Kolibri helicopter. Technical revelations, such as automatically retractable slats, are incorporated in designs, including what's known as the Kruger nose. And aircraft such as the Messerschmitt 262 are put through their paces on test ranges in Texas. German propulsion technologies also give the US a boost when it comes to developing their own new aircraft. The Russians also launched their confiscated A-4s. In 1947, researchers send one up at Kapustin Yar. German knowledge is being applied to achieve Soviet aims, saving researchers trouble, time and money.
We were faced with the question of where and how we could continue the work being done in Germany, because the Cold War had already started. So we were ordered to go out and catch German rocket specialists.
The Russians form what are called trophy brigades in Germany. Their job is to find and take test benches and entire production facilities with them.
It was difficult to do everything the way the government wanted it. And that was, namely, just the way the Germans did, but without using a single German screw. In 1948, we launched the R1 rocket, which was an exact copy of the V2. But we built it of our own material.
The R1 comes after further modifications are made based on German findings. A series of missiles follows, culminating in the R5 in 1956, which is capable of carrying a nuclear warhead.
Sie haben ja diese Technologien alle
They took all the technologies with them. The Americans and the Russians took them, intensively developed them further, and channeled those developments into their own industrial assembly and development. That's something that gets lost. Most only think of the A4 rocket, but everything that was involved with those technologies was exploited intensively by both superpowers. In my opinion, you can't really even put a number on it. The sum that they saved on development costs would run into the billions.
Human reparation is a post-war novelty. The Allies call it the peace dividend. They place German scientists and engineers in their service, in some cases by force. In the US, Wernher von Braun is soon viewed as the most important POW from World War II. He and his team quickly come to dominate US missile and rocket research. In 1949, they test-fire a two-stage rocket based on the A4. It reaches an altitude of 400 kilometers.
It was almost from a standpoint of plunder in war, a unique moment in human history, because this was a case where science and technology was one of the greatest prizes that the Allied forces wanted to seize, after, obviously, the objective of winning the war militarily. And so there was a lot of improvisation going on as people were saying, we really got to take these people, we really need to grab this technology. And part of this was the upshot that the United States took a lot more German scientists and engineers than I think anyone had ever anticipated.
At Redstone Arsenal in Huntsville, Alabama, German scientists used the design of the V2 to create the Redstone rocket, which is first used in the Korean War. In 1961, it's also the rocket used to launch Alan Shepard on the first manned US mission into space.
It had a lot of influence. Of course, when you look at the first large American nuclear missile, the Redstone, that was very much derived from the V2. The first satellite vehicle, which is shown in this hall, is derived from the Redstone, which is derived from the V2. So obviously there's a significant amount of influence there.
US troops sift through the ruins in Germany, looking for documents pertaining to Nazi aerospace research. Engineers from Boeing are also along for the ride. They make a sensational discovery.
The American experts immediately recognized the significance of this document, and George Schirra wrote a letter to Seattle right away. You can still read it in the archive at Boeing. In short, what the letter says is, throw away everything that you've done up to now. We found a new wing in Germany.
Boeing's chief aerodynamicist George Schirra writes home about it. The newly rediscovered German innovations lead to fundamental changes being made to the design of the new Boeing B-47 bomber. A bit later, engineers in the US begin working on innovative turbojets. In October 1947, an F-86 with swept wings makes its maiden flight. It's a spectacular example of the benefits of utilizing the fruits of German research. Only 2 months later, the first Russian fighter jet with swept wings, the MiG-15, takes to the skies. In Paris in 1955, a treaty is signed that ends the occupation of West Germany. Much of the country's sovereignty is restored. Now the watchword is progress. The West moves on to new well-being and a new lease of life. Even Germany's airline, Lufthansa, is allowed to return to the skies after a decade on the ground. By 1953, old research institutes are already up and running. The The 1950s are a time for experimentation. 1954 is also a watershed year for new developments in East Germany. Aeronautics engineer Brunolf Bader, who'd been a prisoner in the Soviet Union after the war, presents his Bader 152 in Dresden. It's the world's first four-engine passenger jet. It's a sensational presentation and demonstration of superiority in the heavens. But in 1959, the USSR quashes the whole project. The message is clear. The development of civilian aircraft is to be curtailed in Soviet-controlled East Germany.
At the beginning of the 1960s, the German aviation industry moved into a new phase. They were working on an experimental aircraft that would take off vertically. Building an aeroplane that did not need a runway had always been a vision.
April 1963 sees the debut of Germany's first vertical short takeoff and landing aircraft, the VJ-101 fighter. It's a high-wing aeroplane, and its engines are located at its wingtips.
The vertical short takeoff and landing aircraft poses a particular problem when it takes off and still has no forward speed. It has to be stabilized because the rudders don't work. They only start working at a certain airspeed. But the aircraft isn't moving, it's hanging in the air like a helicopter. Trimming systems were developed that later benefited other aircraft. The fruits of vertical start aircraft development in Germany could later be seen in the Tornado and in the German know-how that was applied on the Airbus and can still be seen in the control systems that we use in the Airbus today.
The Dornier 31 is the only steel transport plane in the world that takes off vertically. Europe also wants to make it into space. In 1962, a decision is made to build a rocket, and nearly all the aircraft and engine builders want in on the project. Germany gets the job of making the technologically demanding upper stage known as Astris.
If I remember correctly, the first technical experiments started again in 1959 because they could use the old classic big test and proving ground at Traun again. It was a big complex compound. And it's very interesting. It came through the war unscathed, without losing a single screw. Starting in 1959, DFVLR engineers and researchers came back to the compound for the first time. They started to build the first test bench and re-equipped the facilities that would later be used intensively by ERNO, the North Development Circle in Bremen.
The aeronautical engineer Eugen Sänger becomes the head of the facility at Traun. A German spaceflight pioneer, he'd already designed the Silverbird spaceplane in 1943. The planned European rocket proves to be a flop, primarily because the French, British and German developed stages fail to work effectively with one another. After 12 unsuccessful launches, the program is curtailed in 1973. After Germany regains control of its airspace in the 1950s, work begins on the first rotary wing aircraft. Test flights are carried out with new prototypes, but many of these designs remain incomplete. At the beginning of the 1960s, Dornier produces an unprecedented one-seater helicopter, but there's no market for small choppers. Meanwhile, several German firms, among them Borgward, are racing with one another to build the first practically usable helicopter. New research complexes are built during that period. The German Laboratory for Aviation, the DVL, moves to Portswahn near Cologne in the late 1950s. Work also resumes in Braunschweig, Göttingen, Oberpfaffenhofen and Stuttgart. In 1969, the DVL merges with two other research institutes, the DFL and the AVA, to form the DFVLR. Its aim is to make up for lost time by building on the successes that came in the decades before Nazi Germany's defeat. More than 2 decades after the closure of Peenemünde, Germany once again sets its sights on the stars. In 1969, Azur becomes the first German satellite to be put in orbit. The research probe investigates the magnetosphere and the aurora borealis. Germany now becomes involved in the satellite business. Nevertheless, most of Azur's components come from the US, and the US supplies the launch vehicle as well. The success of Azur enables Germany to reach an ambitious partnership with the United States. In 1974, the twin probes Helios A and Helios B begin studying the Sun. The two solar probes are built in Germany, with the US taking responsibility for their launch. They have an estimated life of 18 months, but continue sending data back from space for a decade.
1, 0.
A dream comes true when the first supersonic passenger jet makes its maiden flight. Concorde premieres in 1969 and is hailed as a flying wonder. The distinctive delta-shaped wing was developed by Dietrich Küchemann, formerly of Göttingen. And Karl Dötsch, working in Braunschweig, laid the groundwork for the aircraft's attitude control system. But the Concorde remains a luxury model. Only 16 of the supersonic planes are built. Another aircraft will soon become the pride of Europe. The A300 is the first plane the Europeans build jointly, with the aim of challenging US dominance in the civilian aircraft industry. The Airbus is going to be more modern and economical. Senior German politicians attend the unveiling ceremony in Hamburg in 1974, including Bavarian State Premier Franz Josef Strauß and Hamburg Mayor Hans-Ulrich Klose. Europe is back in the skies.
Also hat man sich schon Mitte der 60er Jahre.
By the mid-1960s, they had managed to sort out a plan to get a joint project up and running in Europe.
Auf die Beine zu stellen.
Politics and industry closed ranks at the end of the 1960s. Germany, France, Spain and Britain all said they were ready to join in and gave the world the Airbus, the company Airbus Industries in Toulouse in 1970, and the first project, the A300.
In 1972, the A300 is the most modern civilian aircraft of its time. More than 600 of them are built. 4 countries are represented in the consortium that builds Airbus. Division of labor is done according to expertise. The British build the wings, Germany part of the fuselage and the tail, and the French the fuselage interior and cockpit. Assembly is in Toulouse. The name Airbus stands for flying as an everyday activity. Germany and France try to achieve independence from the US space program by cooperating in the development of a communication satellite, Symphony. But the failure of the Europa rocket means they have to seek US help to put their satellite into space, and the US won't let it be used for commercial broadcasting. To increase their influence in the club of countries that have mastered spaceflight, Western European nations formed the European Space Agency ESA in 1975. Its task is to promote the scientific and technological interests of its member countries. The first German to venture into space comes from the eastern part of the divided country. On August 26, 1978, Zygmunt Jähn hurtles into space on a Russian Soyuz rocket. For 7 days, Jähn carries out experiments aboard the Russian space station Salyut 6. Using a new multispectral camera, the MKF-6, he photographs the Earth. The new device sets the standard for space cameras. East German experiments and technologies are also carried into space aboard Soviet space probes. East Germany pursues a small but technically ambitious space program at its Institute for Space Research. The Airbus family is established, and with it a whole new set of innovative mass-produced technologies. A new concept for steering a plane comes to fruition with the A310. Fly-by-wire systems and a fully electronic cockpit pave the way for planes guided only by a pilot and a co-pilot. In 1972, DFVLR gets its own test aircraft, the HFB 320 Hansa-jet. It becomes one of the most important research aircraft for aeronautical engineering and flight guidance. In 1973, the aircraft is the first to be guided using fly-by-wire technology.
Weil die Signale nicht direkt vom Piloten
The signals go through a computer instead of going directly from the pilot to the rudders. That means the computer can be programmed so that it first recognizes the aircraft's limits and maintains them, so the pilot cannot voluntarily make it fly too fast or too slow. The plane won't do it. It corrects itself. And the cockpits of all the Airbus aircraft can then be nearly identical, including the indicators and instrumentation. The changes are only stored in the brain of the computer. The computer knows I'm sitting in an A340 or an A320 and in an A380. With only small exceptions, the pilot is always confronted with a cockpit that's the same.
The A310 is not only the most highly developed aircraft of its time, it's also the first civilian airliner in the world to have supercritical carbon fiber wings designed for airspeeds just below the speed of sound. The wind tunnels at DFVLR are used to carry out air current simulations on the supercritical wing. The tests serve to develop new wing prototypes for flight at upper subsonic speeds.
Diesem Profil wurde
The Airbus 310 marks the first time that a civilian airliner was equipped with this profile in Europe. The USA initially objected when this became common knowledge, and there were fears of a lawsuit based on patent violations. But fortunately, it was possible to prove that a German patent had already been issued for the technology in 1943. So the American claim was moot. If that hadn't been the case, there could have been legal problems with the A310.
The world looks on in awe as Europe makes its way into space without superpower help. The Europeans cooperate to make their own booster rocket, resulting in one of the most successful rockets of all time, the Ariane.
We had to see to it that we were standing on our own 2 feet and became as independent as possible from the Americans, who were our main partner at the time. But they already knew that would only succeed if we had the most important part as well, our own payload-carrying rockets. We could build satellites on our own in the 1970s without help from the US. Having components delivered from the US was no longer necessary. But if you wanted to launch them, then you needed to put something on the launch pad in order to be completely independent.
The first Ariane departs on its maiden flight from its launch site in French Guiana on Christmas Eve 1979. Never before has a launch been so smooth. Ariane is alone at the top when it comes to commercial success. In the 1980s and 1990s, the Ariane 4 can't be beat when it comes to launching the world's satellites. Germany also joins in the US space shuttle program. For West Germany, it's the start of manned spaceflight. The European Space Laboratory is conceived and developed in Germany. Space Lab is tailor-made to fit in the space shuttle's cargo bay. German leadership provides Europe's space program with a stroke of genius. Even though it doesn't have its own rocket suited for manned spaceflight, European astronauts are still able to take part in routine missions into space. The arrangement is unprecedented, Space Lab's status as the most ambitious project to date in the history of European spaceflight. On German astronaut Ulf Merbold's first flight in 1983, he accompanies Space Lab into orbit. Never before have so many experiments been carried out during a single spaceflight. 16 missions with a total of 110 astronauts, 181 days in space, 720 experiments before Spacelab is decommissioned in 1998.
Spacelab could be described as Germany's dowry. The Americans profited from it immensely if you estimate the financing. For the first time, we supplied what was going to be carried in the cargo bay of the space shuttle. The lab was completely integrated in the cargo bay. That gave German scientists and researchers a place to run their experiments. And the configuration has continued to work until this day. It's on the International Space Station as well.
Germany runs the D1 and D2 missions. Zero gravity research is the name of a new space discipline. Germany uses Spacelab intensively. For the first time, operations within the shuttle's cargo bay aren't led by the US. Instead, mission control is at the German Aerospace Center at Oberpfaffenhofen. On the 7-day D1 flight, Ernst Messerschmitt and Reinhard Furre carry out research together with their colleagues as they orbit the Earth 110 times. The data gathered provides researchers material for years of groundbreaking work. 75 experiments are on board. Some look into the effect of zero gravity on biological and medical processes. In 1993, Hans Schlegel and Ulrich Walter take off on the D2 mission. The Europeanization of aeronautics research is also progressing. In 1980, the German-Dutch wind tunnel, Europe's biggest, begins operation. Along with it, Germany takes a step closer to the pinnacle of global aviation research. Airbus becomes a serious rival to Boeing. Germany takes off into the future of air transportation with the addition of the VFW 614 ATAS to its research fleet. Starting in 1986, the new aircraft gives German aviation research the first flying simulator. The plane allows researchers to gain insights that can't be obtained by computer simulation. With the ATAS, the behavior of new plane designs can actually be simulated in flight. Carbon fiber construction technology ushers in a new age for aviation and a technological leap in international aircraft manufacturing.
This
design has enormous advantages. The surfaces are much smoother than they would be if they were made of wood or metal. Above all, you can create shapes that are significantly more aerodynamic. Airbus started using carbon fiber instead of fiberglass with smaller surfaces, control system surfaces, spoilers, and then complete tail units. They had to use carbon fiber because of the high demand for stiffness. Airbus was a pioneer in this area. Airbus was the first company that made tail units completely out of carbon composites.
On November the 9th, 1989, the Berlin Wall is breached. German reunification brings with it the dawn of a new era for German air and space research. DFVLR becomes DLR. Times are also changing for European space research. The intensive use of the Russian space station Mir by Western European astronauts begins. In 1992, Klaus-Dietrich Vlader, a test pilot from the German armed forces, the Bundeswehr, goes into space as a research cosmonaut on a mission to the Russian space station. Ulf Merbold follows in 1994. At this time, Germany in particular is able to profit from decades of close East German contact with Moscow. In 1995, Thomas Reiter heads into space. He spends 179 days aboard Mir. Reinhold Ewald does research aboard Mir 2 years later. With his Russian colleagues, he works in space and lands in the snow on the Kazakh steppes. In 1997, the Cassini-Huygens space probe starts out on a joint European-US mission to Saturn and one of its moons, Titan.
2, 1, and liftoff of the Precision spacecraft on a trillion-mile trip to Saturn. That's it.
Deutsche Forschung hier, die in den Instituten
You will
entstanden.
find the fruits of research done at German institutions everywhere, whether it's the Titan or the landing of Huygens, or if it's Cassini.
In Cassini ist, denken Sie an den
Think about the Mars Express. That means we have very good linkage between research and industry.
Industrie.
And you have to remember to keep watering this plant conscientiously, because today we are in a position to be completely self-reliant when it comes to spaceflight. We don't need to rely on help from anyone today. We can handle big projects ourselves. That's what the developments did starting in the mid-1970s. We don't have anything to be ashamed of.
Wir brauchen uns da nicht zu verstecken.
In the summer of 2003, Europe's first independent mission to another planet, the Mars Express, is launched. On board is a unique high-resolution stereo camera. Built at DLR, it allows for the creation of high-resolution images of planetary surfaces in color and 3D. After 45 years of the closest of cooperation in spaceflight, Europe is now on equal footing with the US and Russia. After France, Germany is the second most important partner in building the Ariane 5. The heavens are still the limit. With Europe's global satellite navigation system, Galileo, the aim is to provide the world with reliable positioning information. A civilian project, the planned Galileo satellites promise to be more reliable for users on the ground than the US or Russian systems. A Russian Soyuz rocket is used to take the first Galileo satellite into space in 2011. In 1984, a number of countries begin to pursue the aim of operating an international space station. The ISS is one of the greatest technological ventures in human history. It not only serves research, but also promotes understanding between peoples. In 2006, Thomas Reiter becomes the first German astronaut to work aboard the ISS and outside the spacecraft. During the first long-term European mission on the ISS, Reiter carries out 33 European experiments. He's also the most experienced astronaut in the ESA crew.
Zweifellos ist die ISS ein technologisches.
The ISS is undoubtedly a moment in technological development that will last beyond this period. I see the point of this station less in a purely scientific sense than as a station that links political systems to one another.
Die politische Systeme miteinander verbindet.
It is a station that led to international cooperation between East and West, and as a political symbol, it has already achieved a great deal.
Hat sie schon eine ganze Menge erreicht.
Another high point in aerospace research comes in 2008. After a decade in development, the European Space Laboratory Columbus docks with the International Space Station, the ISS. A period in which Europeans are always in space begins.
Columbus costs money. Spaceflight isn't exactly cheap, yet compared to other things, it isn't quite as expensive as some say. Spaceflight is a cultural thing for me. Humans always push their limits. Really serious research into weightlessness first came with Columbus. Earlier, people spent a few days or weeks in weightless environments. That was child's play. This is only possible now because we have Columbus. A fair assessment of whether it was really worth it will only be possible in a few years' time.
Launch Lego in the lower left. also of the European Space Agency.
Just as with Space Lab years earlier, the German Space Flight Control Center at Oberpfaffenhofen monitors and guides the mission. The next highlight comes a few weeks later with the countdown for the unmanned Automated Transfer Vehicle, or ATV, Jules Verne. An Ariane 5 rocket takes off from the European spaceport at Kourou. The launch is just the start of a stunning premiere. The European Space Transporter approaches the ISS from a position 30 kilometers away. Docking takes place automatically.
The ATV is the most modern spaceship that there is today. It was built in Europe. Many people aren't aware of that. As always, they think if it's spaceflight, it has to come from the US or Russia. Approach and docking are completely automated. There's no ground or space station flight control. The ATV does all that on its own. The ATV is Europe's masterpiece and shows that it's also in the same league with the great powers in spaceflight.
Großen Raumfahrtmächte mitspielen kann.
New aircraft are available for aviation research. One of them is HALO. The modified Gulfstream 550 is a high-performance, high-altitude research jet. It can probe between the troposphere and the stratosphere and carry 3 tons of instruments to altitudes as high as 15 kilometers. What's more, it has a range of more than 8,000 kilometers. In 2010, a cloud of volcanic ash emanating from Iceland as good as grounds air traffic over Europe. The situation presents a special challenge for DLR's Falcon aircraft. It's the only research plane in the air and flies missions to take measurements. A Dornier 728 has been rigged up in Göttingen to give researchers an opportunity to use lasers to analyze the quality of air in passenger planes. Moderate temperatures and relatively still air are said to be optimal. Data from this test will allow airlines to set themselves apart from others by offering passengers the most comfortable in-flight environments. The search for the shape of the aircraft of the future continues. At the Center for Computer Applications in Aerospace Science and Engineering, CASE, at DLR's Braunschweig facility, flight characteristics and aerodynamics of prototypes can be simulated even before an aircraft makes its maiden flight. A unique aircraft makes a futuristic debut. Antares burns hydrogen and is the first plane worldwide with a fuel cell-driven powertrain that can take off powered by an electric engine.
In the case of flight, it's a matter of proving that it works and that flying is safe. None of us would like it if new approach methods or wing flaps were tested on regularly scheduled flights. The industry needs facilities like the German Center for Air and Space Research. Research can only be carried out with your own fleet of research aircraft.
The premier plane in Germany's aviation research fleet is the A320 ATRA, or Advanced Technology Research Aircraft. It's introduced at its new base in Braunschweig and given a legendary name.
I christen you Otto Lilienthal. May you always have good flights.
A DLR aircraft makes an unusual appearance just to taxi. A fuel cell powers 2 electric motors in the nose wheel. Researchers discover that noise and exhaust emissions can be clearly reduced using this technology. A machine walks into the future with a light touch. Is this a design that could be used for coming space missions? At the moment, the insect-like robot is only a prototype and testing platform for the development of different movement and control strategies. The mobile humanoid robot Justin also has a number of considerable accomplishments. With his comprehensive set of sensors and highly sensitive joints, he's able to recognize transparent glasses, open bottles, and pour drinks. Noise is increasingly becoming a problem for aviation, particularly when it comes to takeoff and landing. Scientists are working on developing new low-noise engines. Among the modifications are altering the combustion chamber and turbines. But they're also looking for ways to reduce the noise of air moving around the flaps, landing gear, and other components. Landings are particularly noisy. New systems are being tested. One is GBAS. Results from the ground-based augmentation system can be used to devise ways to make quieter approaches. GBAS permits steep and curved approach routes as well, and these lead to considerable reduction in aircraft noise. It's dangerous in space. Now, a laser-based system is to inventory space debris in order to prevent damage to satellite systems.
You could say that space junk is the bill for the carelessness of the first 4 decades of space flight. Space agencies gave no thought to what would happen to the leftovers, or to old satellites or the stages of rockets that are floating around up there. And today there are enormous problems with tens of thousands or even millions of bits of scrap, depending on what size you start counting. These threaten existing spaceflight systems, space stations, satellites, and research telescopes. Space debris is a huge problem.
One future project is a towing service for defunct satellites. At the EPOS research facility, a procedure is being developed to capture, propel, and control satellites in order to increase their useful life. On June the 21st, 2010, the German radar satellite Tandem X is launched from the Kazakh steppe to meet its twin, Terra SAR X, which was launched in 2007. Together, they're compiling a digital elevation model of Earth. They have a view of more than 150 million square kilometers of the Earth's surface for getting the globe's measurements in 3D. With the pair, Germany has a data-gathering product that's unique the world over. No other satellites have ever obtained such a detailed look at the Earth. Fascination with the miracle of flight remains strong, even today, more than a century after it all began. People still marvel at the wonders of motorized flight. German engineers and scientists have made a decisive contribution to technical and scientific advances in aviation and spaceflight. Flying still reflects daring human ingenuity and eternal curiosity. The conquest of the skies continues.